Thanks for joining me. Today we are going to talk about chemical nomenclature. Now, nomenclature is a really complicated word, but it basically just means how we name things, how things are named. So in chemistry, nomenclature is used to discuss how we name chemical compounds and write chemical formulas. So how we come up with those crazy chemical names that you see all the time everywhere. Now, in the official naming system for chemistry is governed by IUPAC, the International Union of Pure and Applied Chemistry. It's this group that decides on the basic standard rules for doing things. What you need to understand is, though, not all industry uses IUPAC nomenclature when discussing chemicals. So when you read the labels on your food or other cleaning products and you see all the chemical names, those are not always going to fit the IUPAC rules. Sometimes they're the old-fashioned names that industry used way back in the day and they haven't changed it. They just keep using the same way of naming things that they've always named, even though the rules have been updated in recent years. So these are the rules, and what we're going to talk about is how we name things using the IUPAC standard rules. Even though that's not necessarily the way you're always going to see it, that's what we're going to deal with in this class and in these videos. So the IUPAC system has different rules for different types of compounds. There are a lot of different classes of compounds. You have organic, you have inorganic, you have ionic and covalent and acids and bases and all of that. What we're going to focus on in this class setting is inorganic ionic compounds, binary covalent compounds, and acids. So we're going to talk only about how to name these specific types of compounds. So let's start with ionic compounds. Ionic compounds come in two varieties, two basic ways of talking about ionic compounds. We have binary ionic compounds and polyatomic ionic compounds. And the names kind of should tell you a little bit about what they are, because as I've said previously, scientists are not super creative when it comes to their names. Typically, the names for things tell you exactly what it is. You just have to know a little bit about the Latin or Greek or Germanic roots of the words that they use. But typically, the names for things tell you exactly what they are. So a binary ionic compound is a compound consisting of only two elements. Bi meaning two. A bicycle has two wheels. So binary means two. Compound consisting of only two elements. Now I want to make sure you understand, this is different than when we talked about the diatomic molecules where it was two atoms of the same thing. Binary refers to two elements, not two atoms. So example here, we have Fe2O3. It's two iron atoms, three oxygen atoms. We have a total of 5 atoms, but only two elements, iron and oxygen. So it is a binary ionic compound. It's an ionic compound made up of two elements. That's the type of thing that we're going to talk about. Now, in order to name a binary ionic compound, you need to know the charge of the ions formed when the elements are stable, that oxidation state, that oxidation number, the charge number that we've talked about in a previous video. So you need to go back and look at that and know that the columns on the periodic table can help you with that. You have your first column has one charge, column 2 has a charge of +2, column 13 has a charge of +3, and then you have plus or minus 4, -3, -2, -1, 0, all of that we talked about in a previous video. You can go back and look at those. But then you have all those ones in the middle, the transition metals, the intertransition metals, and what we call the post-transition metals, which are all those metals in groups 13, 14, 15, and 16 that are underneath the stair-step line on the periodic table. Well, they're called post-transition metals. Many of those metals have more than one possible charge. So because they have more than one possible charge, when you're dealing with the names, the name has to tell you which version of the element you're using. Whether you're using iron with a +2 charge or iron with a +3 charge has to be told to you in the name of the compound. The IUPAC system does that by using Roman numerals. Now, you may be familiar with Roman numerals. You may not be. We don't use Roman numerals much nowadays in our society. About the only time I ever see Roman numerals now is when I'm watching the NFL championship game and they show you the number of the game is done in Roman numerals, except for number 50. That was the only one they didn't, because they didn't want it to be an L. But anyway, so Roman numerals, if you're not familiar with them, here we go. 1, 2, 3, 4, 5. That's pretty simple. Most people are kind of familiar with those. And then you have 6, 7, 8. These are the ones you're going to be using most of the time. You'll pretty much very rarely use 9 or 10, but I'm going to put them up there anyway, just so that you can be familiar with what they are. So these are your Roman numerals that you need to be familiar with. So the Roman numerals tell you the charge of those transition metals. That's how we do that in the IUPAC system. Now, polyatomic ions, we've had the binary ionic compounds and we have polyatomic ionic compounds. A polyatomic ion is a covalently bonded group of atoms that has a positive or negative charge. So don't be confused. It is a covalently bonded group of atoms, but they all together have a charge. So they are an ion. So it is an ionic thing. They form ionic bonds with metals. What you need to understand, though, is that almost all polyatomic ions are negative. So they're always going to be anions, and they combine with a metal ion. An exception to that is ammonium. Ammonium is the only common polyatomic ion that has a positive charge. And I will give you a list of polyatomic ions that are common that we're going to use for you to do. And there will actually be if you're watching this on YouTube, there will be a link in the description below to a reference sheet that has those on it. So polyatomic ions that contain oxygen are called oxyanions. They're an anion that contains oxygen. You're either going to need to memorize or look up the various polyatomic ions. And as I said, I will give you a list of common polyatomic ions. For those of you that are in my class, if you're watching this on YouTube, there's a link in the description below. So let's talk about acids. Acids are ionic compounds in which the cation is hydrogen. So most of the time an ionic compound is a metal cation and a nonmetal anion. Well, you have a special class of acids where hydrogen actually acts as a cation, a positive ion. So it is an ionic compound. It acts like an ionic compound in a lot of ways, but it does not contain a metal most of the time. So that's what acids are. We are going to spend an entire unit later on discussing acids. Right now, we're just talking about how to name acids. You have two different kinds. You have binary acids, which are acids that have hydrogen as a cation and a nonmetal element as the anion. So you have a cation and an anion, and it's binary. You have hydrogen and one other element. Then you have an oxyacid. An oxyacid is a cation polyatomic ion, hydrogen as your cation, and a polyatomic anion as your anion. So you have a polyatomic oxyanion is your anion. That's what makes it an oxyacid. Hydrogen is still the cation. If it's an acid, hydrogen is the cation, the positive ion. Now, there are other polyatomic ions that can combine with hydrogen to make acids that are not oxyanions, and those are actually going to be named more like binary acids. We'll deal with that when they come up. Now, a binary covalent compound is the next type of compound that the IUPAC system we're going to deal with. A binary covalent compound is a covalent compound made up of only nonmetals and two nonmetals. So you have a nonmetal and a nonmetal, a binary compound. So binary still means the same thing, two elements, and they're both nonmetals. Now, for the most part, if hydrogen is one of your nonmetals, it's going to be named as an acid. There are exceptions that may come up at from time to time, because with everything there are exceptions to pretty much every rule. But for the most part, when you see hydrogen combined with another nonmetal, it's going to be named as an acid, especially if hydrogen is the first one listed. So the IUPAC rules for covalent compounds use Greek prefixes. Now, I'm doing Greek prefixes because not all of these are actually Greek words. that could be Latin or some Germanic or Russian roots. I just am going to use the term Greek prefixes just so for simplicity. A lot of them are Greek, and so I'm just going to say they're Greek prefixes for us to be able to talk about it a whole lot easier. It's the covalent prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So these are the prefixes along with the numbers of what they represent. So we use these prefixes to represent numbers of atoms in our IUPAC system. So what I've done just now is gone over a whole lot of vocabulary. What I'm going to do in the next video is actually go over examples of how we use all of this information, all of these vocabulary words, how we use that to actually name it. Now, I could just go through and outline all the different IUPAC rules. I'm not going to do that. What I'm going to do is I'm going to provide you with what I have created is a flow chart of questions to ask yourself that leads you to the correct way of naming and writing the formula. This will make a whole lot more sense once you see the examples, so please stick around, watch the examples, and get yourself a copy of that nomenclature flowchart. Thanks for watching. See you in the next video. Have a day.